I work in the transportation industry, and several decades ago we would decide where to build a road and we would go build a road. Today it's much more complex than that. First of all, we're much more involved with the public in finding out what the public wants and where the public wants it, how to meet their needs. We're also much more involved with the overall picture. It's not just about the road, it's not just about the transportation, it's about the community, it's about the environment, it's about serving the population's needs. So it's just a much more complex and diverse system that we work within.
The world is more complex. The nature of the engineering profession is very multidisciplinary. We solve problems that cross various lines because of the nature of technological advance in the last number of years. And so it's not any one discipline that's needed to solve any particular problem. So as all that's become blurred, most of us have needed to learn to deal with folks inside and outside of the profession, and certainly across a big breadth of the technical knowledge that's part of the engineering profession.
Today the fields in many areas are merging. Take one example. There are now factories that the employees are bugs, tiny microbes that convert, for example, waste material or grasses into fuels or into the basis of plastics. And if you're not happy with a particular kind of plastic you get, you engineer the bug to produce a different kind of plastic, just like you go into a factory and ask people to run a process differently. So, you know, we didn't think in the past that engineering would involve taking grass and converting it into plastics or fuel. So it's a whole new field that understanding of which is going to be essential to engineers.
Some people argue that all these new complexities can be just learned on the job, and we don't need to do that in the university. Well, these brand new technologies aren't known on the job. I can't teach them to people who work for me. People that work for me can't teach the next generation because they don't know them. This stuff has to be learned in an academic environment and then brought out and applied and adapted in practice.
When we recruit and hire new engineers, we're looking for that additional educational experience.
We can't supplant or replace what they're not getting in their bachelor's program in our fast-paced world right today.
I hear a lot of concern by practicing professionals that if we raise the bar, we will push potential for future professionals away. We'll push students away. It's not true. The evidence here is we've been recruiting students to the University of Alabama based on raising the bar, that this is coming, how about you be in front of that wave? And we've seen an increase in our undergraduate enrollment from around 200 to over 600 students, and our average ACT has increased over 2 points. We're seeing more, we're seeing better, they're excited, they're up for the challenge, they want the bar raised.
The traditional four-year degree doesn't provide the depth and breadth of knowledge today that it did in the past, and isn't by itself adequate enough for an engineer coming into one of our firms without some additional training and education to be really truly ready to become a professional engineer.
What is it that a graduate from Georgia Tech can offer society and can offer in terms of their own capabilities that will be competitive with the capabilities offered by other countries and engineers in other countries who will work for lower wages? And how do we justify our higher standard of living for the engineers here in this country? And my feeling was that we will have to have engineers who are more adaptable, who are more creative, who understand the global economy that they're competing in, and who are willing to look for solutions that perhaps might not be obvious on the surface.